Okay, you all are able to see my screen?
Yes, sir. Yes,
Yeah.
sir.
Yeah, good morning to all of you. Today we shall see what Q data structure is and how we can build it to carry out some important operations on them. So Q, as you all know, is a FIFO data structure, that is first in, first out. This is in contrast to stack, which is last in, first out. It means what goes in first will one which will come out first. So you can think of Q as an array of objects here. As you can see, this is a array starting at index 0 and ending at max size minus 1. Now here we need to keep two indices for front and rear. In stack we had only one, the top index, whereas here we require two because we need to add objects from the rear and delete objects from the front. So always the addition will happen from the rear, or insert will happen from the rear end, and deletion will happen from the front end. Okay. So let's see how we can do all these operations on the Q data structure. Now the reason why we have set front and rear to -1 is that this is a condition indicates that Q is initially empty. Okay. Now if I say insert Q and pass some value X, this X when you insert, now rear is -1, this has to advance to the first position. So before you add an element, you must increment rear by 1. So rear equal to rear plus 1. This is the first thing that we do. So what will happen? Rear will become 0. -1 plus 1 is 0. So rear will point here. Front will remain at -1. And after this, we have to say, let's say the name of this array is A. So A of rear equal to X. When you do this, this X will get stored in the first position. Assume that X equal to, let's say, 9. So 9 will go here. Okay. And now if I want to insert one more, let's say X equal to 3. Again, you have to do rear equal to rear plus 1. This time it will become 1. So at index 1, this rear will point here and you are going to store A of rear equal to the next value, which is 3. And this rear pointer has moved to this position. The front will remain at -1. So -1 doesn't mean Q is empty. And if you want to delete something from the Q, you are not going to pass anything, but you will be returning some data type int, let us say. Now before deleting, you just have to check whether Q is empty or not. If empty, you have to say empty, deletion is not possible. Otherwise you have to increment front by 1. You have to make front equal to front plus 1. So now what happens? Front will move to 0. Now you just have to return A of front. So now what happens? This 9 is actually returned back to the calling function. It is not that you are going to physically remove this 9 from here. So the front will point to this location. Okay. So if whenever you want to access the elements from the queue, it should be always from front plus 1. Now since you have deleted the first element, when you display the queue, you should be starting from front plus 1. That is, only 3 should be displayed, isn't it? So we need to write one more function, display, which will display all the elements of this. So you have to say for I is equal to front plus 1, I less than equal to rear, I plus plus, and then just do a cout here. Okay, so before deletion, if you call display, it would increment front by 1, so I will be 0, so it will display 9, and then I will be incremented 1, it will display 3, and since I becomes more than rear, it will come out. Okay, but after deletion, if you call, front will be at 9 and I will start from front plus 1, so only 3 will be displayed on the output. So this addition deletion can just go on like this. Okay, so once you hit the max size, then you cannot add anymore. So that is why while inserting, you should check whether rear has reached max minus 1. Only after that you have to do this operation, rear plus 1, and then insert that element. Okay, and if whenever front reaches rear, for example, if you go on deleting, so front somewhere it will come here. Now front and rear will be both pointing to 11. It doesn't mean there is one element in the queue. It is already reached the limit and you cannot show any elements. So initially front equal to -1, rear equal to -1, that is an empty case. But as you delete elements, if front coincides with rear, in my earlier example I deleted 9, but if I again delete one more, now also front will become equal to rear. This 3 is also marked as deleted and you will not see anything in the output. Okay, so the conditions for queue emptiness has to be checked properly. Similarly, whether queue is full must also be checked while you are inserting the element. All these operations are clear? Hello?
Yes, sir.
Okay, now,
Yes, sir.
now let's see how we can implement this. We'll take a class by name Q, and since we are storing the elements in the array, we'll be taking an array pointer, an integer pointer, and we'll require two variables. One is front, another one is rear. And in the constructor, we need to initialize all these three. So front I will initialize to -1, rear also I will initialize to -1, and within the body of this I will be allocating memory for a equal to int star malloc, then size of int, and then star max size. Now this max size I have to define as a constant, so let's do that here. As define max size, let's say this is 10. So this is initialized in queue, so queue is initially empty. Now we need to define certain operations. So first thing is I want to add something to this, so you will say void add queue, and you need to pass an element to it. Now here first thing is I will check the boundary condition. If rear equal to max size -1, since we are storing elements for starting from index 0, it will go up to max size -1. Okay, it means the queue is full. And if queue is rear is not equal to max -1, you can go to the else part. Here you need to increment the rear by 1 and then add to the array. So I can do both in one step. I would say plus plus array equal to x. That's all. So we are able to add an element x to the queue. Likewise, we can delete one from the queue. Delete queue. And you are not passing anything here. Now before deleting, you need to check whether if rear equal to front. So this is a condition that indicates that your queue is empty. Queue is empty. And since this function has to return something, I will return just -1. Otherwise, what I should do? Return.
Or else you can return the just deleted element.
Yeah. So you should say a of rear.
Rear minus 1.
Rear should be. What should happen to the rear? Rear will remain wherever it is. No?
True. But to front should be incremented. A of rear and front should be incremented.
Yeah.
But first you have to give the front increment, then return.
Pardon?
First you have to define
Yeah,
the
you have
front
to say
equal front plus
front
1.
equal to front plus 1
Ah,
and then return
return
whatever is at the rear.
Yes.
Okay. So this is delete operation, and then finally we can have a display.
Front missing. Front name.
Yeah. Should be T here.
I think now I think for delete, okay, you are deleting from the front, but you are printing the rear, so it might be not the same. So what I'm saying is, you first print the rear and then delete the. I mean, you note down the particular variable, particular front into the one variable and return it, but you have to increment front is equal to front plus 1, right? So now if you do that, it will be returning from the last.
No.
Yeah.
Yeah. You're right. It should be from front.
But now it will be returning not the deleted one, but it will be returning what is the current one.
Yeah.
So you have to return the
Yeah. You have to.
last.
You have to delete from the front. Okay.
Right.
Here I should increment front by 1 and then return that. So
Okay, true.
all this can be done in one step again. Like
Yes.
I can just
Plus print, yeah.
Yeah, you are right. We have to delete from the front. So front should be incremented and then return that value.
Return, yeah.
Okay. So here I can take one local variable int I equal to front plus 1, I less than equal to rear, I plus plus, and then cout a of I, leave a little space, that's it. Okay, so this is the implementation of the queue data structure, which is of type int. Now let's see it's working. So first thing, I have to create a queue. So queue, first I need to add few elements, add to queue. Queue dot add queue. Okay, and now if I say queue dot display, sorry, I should have 8 coming out first, then 11, then 4 and 3. I think so. One more. Any other error it is showing? Max size. Okay, so there is a mistake in my spelling. Yeah. So we can see 8, 11, 4 and 3. Right? So they come in that order. So 8 is at the front, 3 is at the rear. Now if you had tried deleting the element before you created anything, it would say q empty. Q dot delete. If you try, even before you insert anything, I should get a message q empty. Okay. And you can try q full also by adding more elements, and you will see that when it reaches max minus 1, it would say q full. Okay. Now this is implementation of a integer q. Can I generalize it and make it a generic q?
Template.
Okay, can you tell me how to go about doing it?
Okay. Template T,
Okay,
capital T, and in the Angular basis.
yeah. Type name.
Type T.
Yeah.
Yeah.
Now I need to change this to
T.
indices will remain integer.
Name and integer.
Okay. Anything else we have to change?
There, malloc. Here,
Yeah.
malloc.
Here it should be t star and
T star and size of B. Yes. And
anywhere else?
add Q, int, where we are not sure of what is the type, right?
Correct,
So,
correct. So it should be t.
T. Yes. And
Nowhere else this return type has to change.
yeah, T.
Okay. So these are the changes that are required for this to work. And when you create declare the queue, it should specify the data type.
T.
So it should work as before. Right. Similarly, if I make it double,
It will implicitly convert it, right, sir? If you don't pass anything.
which one?
Meaning instead of 8.4, if you just have passed 8, then it would be implicitly converted to double.
Because last, see, I'm doing that here. Last one, I'm just passing 3. It will be converted to double.
Okay.
Yeah. Okay. So it is able to handle these two data types. But there is one problem here. If I define a queue which is of type string, its behavior is undefined. So we'll see the reason and what is the remedy for that. For example, if I say queue string some names. So names dot add queue. This should be small letter here.
Smallest.
You can add 2 more. And if I say names dot display, let's see if it works. If it is not working, we'll see what is the problem. as you can see, the behavior is undefined. You will not get any output. The reason is when you are allocating space dynamically using malloc, okay, and if type T is of string, it doesn't work correctly. Okay, and for this, all that you have to do is you just have to use new operator. It should be square bracket here, not round bracket. It's an array, no? So we just have to create an array of yeah. Okay, so we are able to insert string objects in the generic queue. So did you follow how a queue works and how to generalize it?
Yes, sir.
Yeah, so would you like to try this out?
Yes.
Okay, just give a try. You can directly try the generic one. So we saw the implementation of a queue which works on the principle of FIFO, first in, first out, and we saw three important operations: add queue, delete queue, and display. We also looked at the demonstration of the same using generic queue, where I can specify the type of queue I want. So the queue with string and queue with double data type we saw, and its demonstration worked perfectly fine. Now, one problem with this type of queue, this queue is also called as linear queue. We shall see a improvised version of this, which is a circular queue. Now the problem with this linear queue is that it is not utilizing the space that is available at the beginning of the array as the deletions happen. So the array should be able to wrap around and come back to the front and utilize that available space. So we shall see the implementation of circular queue in the next session. So until then, bye. Thank you.